So this is the volume of water compartments of a 70 kilogram person. The plasma compartment of 70 kilogram is about 3 liters, and the total body water compartment is 42 liters. Now, it would be simpler, class. It would be simpler, your image. It would be simpler if a drug is added to, okay, if the drug, it would be simpler if the drug was added to the total body and simply distributed evenly between the plasma and the rest of the body. But that's not the case. It would be simple if the drug was distributed evenly as if a single compartment. Pero hindi yun nangyayari masyado. But rarely is a drug distributed evenly. Why? Because what? Okay, let me write that. It would be simple. It would be simple. It would be simple if the drug, it would be simple if the drug was distributed evenly. Was distributed evenly as if a single compartment. But that's not the case. That is rarely occurs. Why? Because we have two compartments, your plasma compartment and the rest of the body. What are the reasons? Because some drugs, you have to note, class, you have to take note that some drugs remain in the plasma, remain in the plasma mostly, not distributed to the rest of the body. Not distributed to the rest of the body. And vice versa. Some drugs are extensively distributed to other parts of the body, just like in the case of a kidney failure. The volume distribution is increased by the kidney failure due to fluid retention, as well as your liver failure. It could be due to altered body fluid and plasma protein binding. Conversely, it may be decrease in dehydration. So, it would be simple talaga if the drug was distributed evenly as if a single compartment. Simple lang sana siya kung ganon yung nangyayari, kaso hindi. If drug was added to the total body and distributed evenly between the plasma and the rest of the body, kaso that's not the case. It rarely happens because what are the reasons? You have to take note. Some drugs remain in the plasma mostly, not distributed to the rest of the body, and some drugs are extensively distributed to the rest of the body. Some drugs are extensively distributed to other parts of the body, or to the rest part of the body, to other parts of the body, the concept of your volume distribution. Again, okay, volume of distribution is the apparent volume in which drug is dissolved and it reaches your equilibrium. So, ang kailangan natin tanda ang mga keywords dyan, very important yan. volume of distribution is again described as the apparent volume. Kaya tinawag din siyang apparent volume distribution. And in which drug is dissolved. And reaches equilibrium. Your equilibrium. So your keywords, we have the term apparent volume, drug dissolve, and your equilibrium, reaches your equilibrium. Okay. Imagine a particular container again. Ayan na naman tayo. Imagine a particular container. In fact, you cannot estimate the fluid content of that particular container. So let me give you an example. Let me give you an illustration again. I have a drug here that is mostly measured by milligram. I have here a weighing scale, and then we have the measuring concentration. Okay, so we have a drug, 1000 milligram, and the measuring concentration is about, let's say 50 milligram per liter. And how concentration are being calculated? Okay, concentration, how they are being calculated is we have your weight divided by your volume. And of course, imagine that particular container, you cannot actually estimate the fluid. So as an estimation, since the formula for concentration is weight divided by your volume, now the question is, how do you compute your volume? By using this equation, we can actually derive the formula. Madali lang, elementary yan. Weight, para makuha mo yung volume, weight divided by, obviously, concentration. Weight divided by your concentration. Tataas lang natin. Weight divided by your concentration. So, let's compute. Let's put it on the equation. Volume is equal to 1000 milligram divided by your 50 milligram per liters. Okay, so we have 20 liters. So your 20 liters is the volume of what? Volume of water in the container. Volume of water in the container. Okay, volume of water in the container. So that's the volume of distribution of drug in our example. Okay. Imagine yung sinasabi ko kanina na container, you cannot actually estimate the fluid. So, pagbibigyan mo ng example yan, I have a drug of 1000 milligram, and then the measured concentration is 50 milligram. So, if you going to put that in equations, 1000 divided by 50, so that's 20 liters. So, that is the volume of water in the container. So, let's assume that's the volume of distribution of drug in the example. This is also similar to human being. Ito, parehas lang ito sa human being natin, class. This is somehow similar to a human being. Sorry, di marunong mag-drawing. Di marunong mag-drawing, di ba? Perfect. This is also similar to human being. Why? If you inject a drug, okay, you have to wait for the equilibrium, and then you have to take sample and measure the concentration. Measure the concentration. Ganun din. Measure the concentration. So, to compute, volume distribution is equal to drug mass, that is the weight, divided by the concentration. Divided by the concentration. But unfortunately, class, though in human being, kung sa container po natin, 20 liters yung kanyang volume distribution sa example natin. Unfortunately, in human being, pag in-inject mo kasi yung drug na yan, okay, you inject this drug, okay, it reaches the blood. Okay, it reaches the blood. So, from blood, it can go through different organs such as your brain, your heart, your lungs, your kidneys, and so forth. So, the concentration of blood actually changes. So, in our example, your estimated volume of distribution is 20 milligram. That's 20 milligram. Yun sa example natin kanina. Tignan mo. Okay, in our example a while ago. In our example, we have 20 milligram per liter. So, if you're going to compute that volume distribution is equal to 1,000 milligram divided by your 20 milligram per liter, that will give you around 50 liters. So, apparently, that is a huge volume than the 20 liters that is in the container. So, that is the apparent volume of the distribution. Drug, because drug moves away from the blood to the organs. So, yung concentration of blood po natin, nababago talaga siya actually. Okay, kaya tinawag siyang apparent volume of distribution or theoretical volume of distribution. Now, let me summarize. So, again, your VD, okay, what does your VD tells us? It tells us how extensively drug, naulit ko lang, drug is distributed to the rest of the body, compared to plasma, compared to the plasma. It is actually defined by the ratio of the amount of drug in the total body to the concentration of drug in the plasma. So, how do you compute? Okay, so here's the formula. Volume distribution is equals to the amount of drug in the body, over divided by your plasma concentration, Okay, so that's the formula. Amount of drug in the body divided by your plasma concentration, or simply, para mas madali, gawa tayo ng tinatawag nating abbreviation, volume distribution, A divided by your plasma concentration. O, ginawa ko lang na equation niya na para mas madali mo matandaan. Volume distribution is equal to amount of drug in the body divided by your plasma concentration. Now, let me give you a particular example. Okay. If a dose of 50 milligram of drug A results in a plasma concentration of 0.1 milligram per liter. Okay, so if you're going to play that in the equation, so VD is equal to, so ilan ang ating amount of drug in the body? That's 50 milligram divided by the plasma concentration, that is 0.1 milligram per liter. That will give you around, okay, calculate, that will give you around 500 liters. You have to take note, class. The volume of distribution for drug A is 500 liters. So the question is, how is it that the volume of distribution of drug A is far greater than any actual compartment volume? Bakit ang taas? O maalala nyo yung example